Sure.
Good morning, good afternoon, or good evening, depending on where you're joining us from today. Welcome to our Densify and AWS integration workshop on enterprise-grade continuous cloud cost optimization. It's a bit of a mouthful, but this topic has shown to be of significant interest. We've had tremendous global registration for this discussion. We will be conducting an everyone on mute session today because of the numbers. We will moderate Q&A at the end. If you'd like to enter questions, please do so through the question console. My name is Chuck Tatham. I'm the Chief Marketing Officer at Densify, and I'm pleased to be hosting the session today. Our agenda is pretty straightforward. I'm going to advance the slide here if I can take control. I'm going to talk a little bit about Densify just so you have a context for what the analytics engine does. And then I'm going to pass over to Brian Terry and Dinesh Ravindran, our dynamic duo from Amazon and Densify, to talk about a project that they've been working on for the last month or two, building this integrated story, and it's an exciting one. We'll talk about the business drivers and why we think this is of such interest to larger enterprises. Toward the end, as I said, we'll moderate a Q&A, and we will do a draw for 2 Nintendo Switches. We'll do that randomly to the individuals that are still on the call. It's an incentive to stay on. If the content isn't incentive enough, then maybe that will be. That's the intro. Why this workshop? Why this topic? We find that cloud infrastructure cost is at an all-time concern is at an all-time high. We don't need to explain why. It's just the climate. Everyone's interested in cost control. Everyone's interested in the agility and speed which is brought by cloud and AWS specifically. But cost control as these environments scale becomes a concern. Infrastructure as code and the speed of DevOps is exacerbating the issue. We'll talk a little bit about that. A big factor, though, in gaining control and driving efficiency is that application owners are naturally resistant to infrastructure change. We'll talk about that, and change for the purposes of optimization even and cost reduction. It's really hard to optimize a complex supply chain, and cloud is a complex supply chain using mixed or disparate tactics. We see a lot of finance and IT finance organizations struggling with this. We'll talk about some of those themes. The great thing is that most enterprises today have established change control processes and systems in place. So why not take advantage of that? And that's exactly what we've done. We've taken off-the-shelf components from AWS. We've added the ITSM flavor. We've added the Densify analytics engine to enable this notion of collaborative, controlled, continuous cloud cost optimization. We're going to show you how it's done. We're actually going to show you under the covers the detail of how it's done, and that's what these guys are going to spend the majority of the time on, is how these things fit together and how we make this feasible. This challenge is really a systemic one, and if you think about any of the deployment mechanisms, the change control and infrastructure management processes in enterprises today, the act of selecting resources is largely driven by individuals who are making educated guesses. A lot of smart people making educated guesses, but in general, these individuals are largely concerned with performance and stability. They're embedding it increasingly in the code. We'll talk a lot about CloudFormation today, but things like Terraform and other mechanisms are making the infrastructure specifications part of the code. We joke a little bit that this is really purchasing as code, but it's this dynamic that is increasingly driving finance organizations batty, and this is the universal symbol for that, because it's embedded and it's harder and harder to remediate over time. And that's really what we're talking about when we dig into this topic. So Densify is an engine, a brain, that's targeted at optimizing cost and resource. We do this in VMware infrastructure, our topic today, public cloud, as well as containers. And when we talk about public cloud, when we integrate this brain into what Dinesh and Brian are going to show, it's about controlling resource consumption or usage, reducing its cost, improving the way you purchase it, optimizing or making optimization a collaborative process by driving and including automated processes. And that's really what we're going to talk about. If we talk about Densify's engine, just to give you a sense, when Dinesh kicks this off and talks about connecting this analytics engine into the mechanism, you need to understand that what we're doing is understanding very deep application demand patterns, so the behaviors of the workloads. We understand all of the characteristics, the performance characteristics, the cost models, the technical constraints of the AWS offerings. We combine that with deep tagging and a policy engine. The policy engine allows us to specify what is fit for purpose for a class of workload. You don't treat production critical the same as dev test, let's say. And what the engine is constantly doing is a permutation analysis to come up with the right matching between workload and family and quantity of resource. And what comes out of it are what you might think of as optimization directives. They are precise, they are actionable because of their precision. They are really the truth about what your workloads need. And we would break those down into the allocation of the resource, the placement of the workload where appropriate. If you want to consider a hosting change, moving things around, what would you do to do that optimally? And then how do you optimize the purchase of all this, which is tightly tied to the precision and the truth of what the applications need. Now, these answers, the output, and this is the heart of the matter that Dinesh is going to dig into, can go to people and reports. There's always need for that. But increasingly, you've got to get it into an approval process, a collaboration environment, so that the people that need to approve can say, okay, and those answers can go to execution and be made so. Because unless those actions are completed, the optimization doesn't happen, the costs don't go down. Now, if you think of this in the context of the overall cloud spend, finance can get at reserved instances and savings programs. That's a wonderful thing, and AWS makes tremendous discounting available if you do that well. But you've got to get at the optimization of the instances, the instance level optimization. And that's what we're going to show you in a tightly controlled process so that you can get it done and address the complete problem. Now, our best-in-class customers treat this as a collaborative and integrated process because it can't be just finance dealing with this. You've got engineering and ops that need to know that applications are healthy. You've got finance needing to know that it's at the right cost. And leadership, of course, knowing that it's agile, reliable, and aligned with budget. And when we look at our best case customers, they truly treat this as a collaborative process, because engineering and ops and the app owners need to have the visibility and the understanding of what's happening and know that the infrastructure is reliable and performant. They will only then be trusting of the suggestion of change and approve the actions, because they need to approve, so that you can go and make sure that resources are cost appropriate and that purchases are optimized. And it is this life cycle that allows customers to say, we've done this together. It's not just a problem of finance or purchasing, it's everyone's problem. And if you equip the organization with the right answers, you can do this as an integrated process. And that's really what we're going to show today. And I'd like to introduce Dinesh and Brian to take us through this content. Over to you, Dinesh.
Perfect. Thank you, Chuck. I'm just going to get started over here. Now, I know everyone's eager to see the actual demo, to see what it looks like. Now, before we jump over to that, which we will do very shortly, I'm going to run through a couple of high-level solution overview slides just to give you a bit of context behind the solution that we're going to be showing here today. Just some quick history. Now, this is a project, like as Chuck mentioned, this is a project that we worked on with AWS. And they approached us. They have technology to help you build products within their own environment, within AWS, and even expose these products to ServiceNow and other ITSM platforms. Now, you guys know Densify. Chuck gave a quick overview there. We have the ability of analyzing those products that were provisioned through AWS, analyzing their resource utilization metrics, other technical and business constraints to generate, call it insights around better supply allocations for the observed demand, okay? So what we were trying to solve now is, can we take those insights and implement them at scale for a production AWS environment using an ITSM-controlled process? Okay, so that's the crux of the problem that we're going to be talking about and how we solve that, using a mix of different technologies from AWS System Manager Suite, from Densify, as well as ServiceNow, okay, in this specific demonstration. So we're going to start here with the very first process. And I also want to mention here that I'm not going to get into the deep dive technical software architecture. We're going to stick to the high level processes and the interactions between the different componentry so you can follow along with the demo. Okay, so that very first process I'm going to start here with is stage one. We call it creating new products within AWS and exposing them to ITSM Service Catalog. So these products we're calling continuously optimizing products. They're specialized, they get created within Service Catalog, and they're exposed upward, northbound into ServiceNow or other ITSM platforms. Now, how that happens, my counterpart Brian is going to speak to, but for now, assume that that's the first stage. The second stage is, once that's complete, users of the ITSM platform can now select these continuously optimizing products directly from ServiceNow. So they log into ServiceNow, they go to Service Catalog, and they can see these continuously optimizing products, and they can select them for provisioning in order to support the business use case that they're trying to solve. Okay, so they're provisioning this, and the two technologies that are driving these two processes are AWS Service Catalog, which is where these products are being created by engineering, and ServiceNow, which is where application owners are actually requesting or ordering or provisioning these products that have been created. Okay, so once these products are requested for order, they're immediately pushed downstream into the AWS environment. It first hits AWS Service Catalog. Service Catalog will call an IAC technology like AWS CloudFormation. CloudFormation takes the template which defines the specific products. Defines the specific product, and within that template, you define various different services like EC2, RDS, ASGs, and other services that you want to implement within the environment to make up that product. So CloudFormation goes to a create stack process to deploy that new that set of services that make up that product. Now this happens, and at some point in the future, when these sets of services have been running for a sufficient period of time, then optimization services, specifically Densify here, would collect resource utilization metrics, understanding the demand requirements for those applications based on how it's been running in the past, looking at technical and business constraints to really produce recommendations on more optimal supply allocations for the observed demand. So we have these insights. They're sitting inside Densify. We're calling this the resource analysis state. So we want to begin the process of automating these answers. So how do we do that? The first stage is we're going to go directly to, so what we'll do is we'll actually go to a parameter repo sync. So the idea is taking these new insights and delivering them to the heart of any DevOps pipeline. So in this case, it's a parameter repo. So if you guys know CloudFormation templates or Terraform templates, you're going to have transient parameters or transient variables. Now, these things will continuously change. Best practice dictates that you parameterize these variables, you service them out of a template, and you manage them externally, okay, to a parameter repo like AWS Parameter Store, which can then be quickly referenced by that IAC technology. So this is the reason why we deliver these insights directly to AWS Parameter Store, because we believe they are transient variables. So things like instance type or min or max size for your ASG size or whatnot, these are delivered to this parameter repo and ready for automation. So the act of delivering new insights to this parameter repo triggers what we call now the ITSM collaboration process. Now there's two sub-processes within this collaboration process. The very first sub-process is, even though we have this recommendation, we can't go and implement it in an environment. We need to first seek approval and authorization from both engineering or the application owner that actually deployed the actual, that actually requested the ordering of this product. So we do this by opening up a change management ticket within ServiceNow to say, listen, this is a product that you provision. We've analyzed its behavior, and this is all of the empirical evidence behind why we believe you should reallocate resources. Okay, we can optimize resources, whether it's increasing the resources because it just doesn't have enough, or it's reducing resources because it's just not using any. Okay, so this application owner now has the ability to approve or deny at this point. If they approve, then we trigger the second sub process, which is to acquire a maintenance window. We can't just go and implement it at any random point in time because this could be a production workload running in a production environment. So obviously, if we're going to make supply allocation changes to IaaS technologies within AWS, it may bring down that service to make the changes to bring it back up. So we want to do this in a controlled manner. So what the second sub process is about opening up a work order in AWS Ops Center and routing that to a Cloud Ops resource. So the Cloud Ops resource can now schedule a maintenance window. They can go and say, okay, we got an order to make a change here. I'm going to now schedule it for execution at this specific point in time in the future, so I can control it. And when that maintenance window arrives, the maintenance window doesn't the integrity tests against the specific CloudFormation stack to ensure that the services are running within expected parameters, and then issues a stack update. Okay, so that's going to go through the process now. CloudFormation is essentially going to review all of the different services that it's holding, and it's going to go and try to update it with the approved recommendations from Densify. Okay, now how that happens, I'll talk about in a moment as we progress through this. But once that occurs, this cycle continuously continues, and we call this. And at this point, we say that this product is in a state of ITSM-controlled continuous optimization. Okay. Now, just going back to the left-hand side of the screen, what makes the first two processes possible is this technology from AWS, the AWS Service Catalog connector, which my counterpart Brian is going to speak to right now.
All right. So if we step back and we take a 10,000-foot view of the architecture of the solution and the demo, you may be asking, how are these things being provisioned? Well, to do this, we're using the AWS Service Catalog connector. And this connector we've built for, we actually published for 2 platforms so far, which is Jira and ServiceNow. What this connector allows you to do and our customers to do is provision AWS resources without having to go to the console. And to do this, we use one of our features, one of our services called Service Catalog. So the idea behind Service Catalog is your cloud infrastructure team builds a CloudFormation template. This is our solution for infrastructure as code. They create this template on the best practices of deploying a specific product. So let's say, for instance, in this demo, you'll see me assume the persona of wanting a web server because I'm a web developer. So it's assumed that my cloud architecture team has designed this architecture. They have made it so it was resilient. They made sure that the correct ports are open, and they've made it so that I'm using the right type of instance. And they've taken this template and they've uploaded it to Service Catalog. Now, using the connector, everything that gets loaded to Service Catalog in a specific portfolio that you map to the connector gets loaded directly over to Jira or ServiceNow. So this allows me as an end user to go to one of those ITSM platforms and order a specific product without any knowledge of VPCs, ports, or the best practices to deploy this. All I know is there's a product there, I can place an order for it, and then ultimately that thing is provisioned in AWS once it goes through an approval level. So this allows the customer to put certain approvals around resource set provision. So say, for instance, if I'm ordering a huge database, maybe this needs to go to my manager or this needs to go to finance. All those things can be done within a workflow within these solutions. And once approved, these are automatically provisioned in AWS. So if we go from left to right, you'll see that the end user starts by browsing for the product. They procure the product by selecting which one they want. For instance, this web server, and then it's automatically launched into AWS. A good thing about this is you can also attach other things to these products, such as alarms for monitoring and such. And you can also associate tags for costing. So I'll pass it to Dinesh for the next slide.
Thanks, Brian. So jumping across, so all the different processes that I talked about in the previous slide, I'm going to just go into a little bit of detail on each of the individual processes. I'm going to start here with the product creation state. Now, this is primarily driven by the engineering teams when they're ready to develop or create a new product to host inside their AWS environment. I'm going to call this the creation pipeline, and they begin by creating a CloudFormation template that defines this product. Okay, and in this state, I'm calling it, we're saying we need to embed Densify into the CFD. What do I mean by that? It goes back to how CloudFormation was able to actually acquire the approved recommendations and institute the change. In order to do that, we need to enhance these templates. And we do that by creating an additional infrastructure resource within the template itself. And we call this a Densify lookup plugin or a lookup plugin. And the lookup plugin implements as a Lambda function to essentially go out and acquire the recommendation from any external parameter repo, whatever is configured within its configuration. There's some interesting inputs into this particular lookup plugin. There's some stack details, but what's most important here is at the very bottom, you're going to see some call it hard coding of the actual instance types or the instance sizes. Now, these are actually default values that other infrastructure resources within its template is actually going to take on. So if we take a look at, so right now we're actually looking at two. They're seeing the compute instance and the database instance. If we take a look at one of these other infrastructure resources, say the compute instance, what does it look like? So that compute instance here is defining an EC2 instance. But interestingly, if you look at the instance type parameter, it no longer hard codes that value, that default value. Instead, it's saying, go to the Densify lookup plugin and get me the configuration for this particular input. Okay, so the Densify lookup plugin is now going to provide either an optimal value from the parameter repo, or may even provide the default value that's sitting within its own configuration under certain conditions. Okay, so once this happens, once the template has been enhanced, they can log into Service Catalog to create this product, wrap it in the wrap the CFT template within the product, and finally expose it to ServiceNow for publishing. Okay, so they can be accessed. The second stage here is product provisioning, driven by application owners. They log in and they're executing what we call the provisioning pipeline. So they're going to log into ServiceNow and they can select this continuously optimizing product that was just created by engineering, and they want to implement it because they're trying to solve a business use case that they're trying to solve. So they order this product from ServiceNow. This gets pushed into Service Catalog and ultimately to CloudFormation for deployment inside the AWS environment. So those services now get deployed and they're activated. But how did this actually work? Right, it goes back to that Densify lookup plugin. We know that this thing is going out, grabbing recommendations, insights, and supplying them back to CloudFormation. So at a minimum, we know that this is happening. So where is it acquiring these insights from? Well, it's from parameter store. So it's doing a lookup in parameter store. So at a minimum, we know that the plugin is going to go and provide the optimal values from parameter store back to CloudFormation, so that CloudFormation can institute those changes. Now, what happens in a case where this is a brand new product? It's never, this is not a stack update, this is a create process. There are no insights sitting inside parameter store. What's going to happen? At that case, if you recall the defaults that we specified within its configuration, that's what the lookup plugin is going to provide back to CloudFormation. Say, listen, there are no optimal settings because it's a brand new product. Go ahead with the default settings that the engineering resources have provided for this. Okay. So I'll jump across. The resource analysis state and the parameter repo sync. I'm not going to get into how Densify works here. You guys have already seen it. We support various different use cases. This is the public cloud optimization use case for resource allocation, the workload placement, migration analysis if you want to jump across different hosting venues, and of course the purchase optimization for RIs or even savings plans. All of these insights that Densify generates for these use cases can be selectively delivered to different parameter repos. So in this case, for our solution, we're delivering them to the parameter store, AWS parameter store. And we're going to focus here on, for the purpose of today's demo, on the resource allocation for public cloud IaaS optimization, specifically around EC2, RDS, and even ASGs. Okay? So I'm going to jump across. The next stage here is collaboration. So we've synchronized to parameter repo. How does collaboration work? So the act of delivering a new insight to parameter store kicks off a point source serverless solution that's going to orchestrate the ITSM collaboration process. So this process is built inside AWS, and it's going to start the first sub process, which is to go to ServiceNow to say, this is a new recommendation. Here's the empirical evidence. Can you provide approval? Applications owners can provide that approval. It will then open up a work order against cloud operations through AWS Ops Center to say, there's a new work order. It's been approved for execution. Can you manage this? And they need to, they begin the process by scheduling a maintenance window. So cloud operations can now say, okay, according to my schedule and according to the product that they want us to optimize, we're going to schedule this specific maintenance window. They specify the details in the ticket itself. Okay, this gets picked up and the solution schedules a AWS system manager maintenance window. This is an actual entity that sits inside AWS and the entity will orchestrate the optimization process, okay, or the execution process, I should say. So when that date and time arrives, that maintenance window is triggered. The maintenance window is going to go out and it's going to check the integrity of the stack, and it does this by checking for drift. If the stack is not in a, it doesn't have integrity, or it's down, it's drifted, then it may not execute this. It would send a notification back to CloudOps. But if it's in a good state, a solid state, and it's running, then it's going to perform a stack update. So by issuing the stack update to CloudFormation, of course, is going to go to Densify lookup plugin, say, give me the recommendations or the approved recommendations for these resources that I'm managing, my CFD, which gets pulled from Cloud Parameter Store, delivered back to CloudFormation. CloudFormation can go on and institute those changes inside AWS. Now, once that's complete, the maintenance window will go back to ServiceNow, Jira, to say, listen, Mr. Application Owner, this is the status of your upgrade on your specific application, and this is what happened. This is what's happened in the maintenance window. We'll also go back to Cloud Operations to give them notification of what's happened in that maintenance window, or if further manual steps are required. If there was an issue, then Cloud Operations would be notified with a ticket, and they would log in and correct that and apply corrective measures. Okay. So with that, I think we could jump over to the demo. Brian, I'll let you kick that off. Okay, perfect. So we're going to go ahead and start in demo. Here are some of the technologies I'm going to touch upon. And throughout the demo, both myself and Brian will impersonate different users. I'll impersonate Cloud Operations and Engineering. Brian will impersonate application owners. Okay. So we're going to begin by creating a product, and we do that by creating a portfolio within AWS Service Catalog. So I've logged in here to the AWS console. I'm going to go ahead and start by creating a portfolio of products. We're going to call these continuously optimizing products or optimizing products. And I'll specify an owner here as well. Okay, so we'll hit create. And we'll go into this new portfolio, and we need to assign Brian as a user of this portfolio so then he can provision products from this portfolio. So we'll go in, we'll hit users, and we'll select Brian to add access to it. Okay. Now we'll also add a tag option. This is what enabled AWS to understand that this is a continuously optimizing portfolio containing continuously optimizing products. So we assign Densify enable optimization. So it's assigned to this portfolio. Now we can begin by adding products to the portfolio, and we'll create one product here, a simple product. So we'll specify some details. I'll call this web server, specify an owner. And I'm only going to stick with mandatory fields and skip over the optionals for the sake of time. So I've already pre-created my CloudFormation template. I'll just select it over here. We'll load it into the product. We'll specify the version title as well. Continue down. I'm going to skip over the support details over here. We're just going to review the product and create it. I'm going to refresh the screen, and we can see, and we should, there you go. We see the product there.
Now I'm going to presume the persona of a web developer that needs a web server. For this, I'm going to impersonate an admin user on ServiceNow. I'm just going to do this to make it kind of a quick transition in order to order these products. So what I'm going to do is look at the filter options, filter navigator, and I'm going to type in service, and then I'm going to look for the service catalog connector for AWS. This again is a feed plugin for ServiceNow. So using the connector, I'm going to scroll down and I'm going to look for a web server product. And once I find my product, I see there are a couple parameters that I have to input in order to order this item. But if you'll notice here, there's a special tag called Densify Enable Optimization. We'll talk about this a little later. So in this demonstration, I'm going to give my product a quick name that I can kind of recognize. And you can see in this order form, there are a couple of different options, like I can choose LAMP Stack 3, version 2.14. All these are defined inside the CloudFormation template. So once I create a product name that I'm good with, I can go ahead and place the order for this item. And as you can see, after I place the order for the item, that it'll go through an approval process. But since I'm an admin, it's going to go ahead and just skip a field.
We're actually over at the CloudFormation console, and we can see that product being deployed by CloudFormation. So it's creating all of the necessary underlying services and resources that are needed. We're going to wait. We can actually notice here that the stack has been created. If we take a look at the events, we can see the stack is in a final created state. Okay. If we hop over to the instances, the EC2 console page, I'm going to hit refresh, and you can see that these two the two instances have been deployed. One is a C5.9 extra large, the other one is an M5 large. Okay, now we're over at the Densify console screen, and we can see that Densify has produced certain recommendations against these two continuously optimizing products. Web server, we're saying downsize the thing to an M5A4 extra large simply because it's not using enough resources. And for the database product, we can actually see that we're recommending an upsize to an R5A large, most likely because it has too much utilization. So we can see that by going to that product, we can see that CPU is slammed here at 100%, and by making this change, we can bring CPU utilization down to 80%, which is a specified policy constraint. If we continue to scroll along the top here, we can glean some other details about the recommendations, specifically the cost impact, the effort to actually institute the change, and even the supply allocation details, the hardware constraints. Okay, now Densify will distribute these recommendations directly to a parameter repo, and this is AWS's parameter store. There's various different parameters that you're looking at. The one that we're going to be interested here is in the web server and the database parameters, which is hosting the values for the insight itself. Okay, so if I jump here into the database parameter, I'm going to glean some details. It's set to an M5 large. It's not set to the recommendation because it hasn't yet been approved. So we've created the parameter. We've just set it to its current value, and we're waiting for approval. Okay, so we can continue to track this by going to history. We can actually see that it's been created in the initialized state. So it's waiting there, it's waiting for approval, okay? Now, this will also track other state transitions as we continue through the life cycle of this particular insight. Now, if we head over to, if we want to glean further details about the recommendation, we can head over to tags, and we can see all of the details behind this recommendation that Densify has produced, the empirical evidence, is stored within the parameter itself in tags. We do this for auditing purposes, okay? So if I jump back here to the main console page, before we jump off this, I do want to show you another product that has gone through a complete life cycle, batch loader over here, and take a look at what that parameter looks like after it's gone through this life cycle change. So if we head over to history here, we can actually see that this specific application has transitioned through various different states. It started off in the initialized state, where Densify distributed the recommendation. It's gone into the approved once we received an approval from ServiceNow. Even on to the scheduled state when cloud operations has provided the maintenance window details, it was executed and finally closed by the application owner. Okay, so we see a complete lifecycle transition for each of our insights that are being delivered to this parameter repo. Okay, so with that, I'm going to jump on to the next section.
So now if we go back to ServiceNow, we'll see that we can look up the change records. And if we go search for the specific change record that we're looking for, the recommendation for the web server, we'll search here. All right, and you'll notice that inside the change record, there is a recommendation for the web server and also the database. So let's take a quick double click into the one for the database and take a quick look. And as you notice that in the description, all the information about this change that needs to be requested is completely in the description. We can see that it can go through a full change record ITSM process, it includes a PDF with a recommendation that people can approve this request based upon. And this is delivered directly inside ServiceNow. So they have all the evidence they need in order to scale up this instance or scale down this instance if needed. So I'm gonna go ahead and I'm gonna approve this request. Normally this would go through several hands, but for this demonstration, I'm just gonna go ahead and make this approval.
Okay, so now that the recommendations have been approved, we're in Ops Center over here, and we can see that two ops items have been created. These are ops tickets. Now, this is because Brian had previously approved both recommendations. So we're going to look here, and we can see these two requests, and we'll hit to the database component. We'll see some of the details behind what's in this particular ticket for Cloud Ops. There's some details that we can glean here in the details section. This has been set to SEV critical and category performance because this is an upsize recommendation for that database instance that we're talking about. If we continue down a bit, we can see some related resources that are associated with this specific recommendation, specifically the stack that's driving it, the specific parameter, and even the EC2 instance itself. Now, if we want to glean further details, we can do that directly in the ticket, and we can glean that directly in this particular console. Now, I'm just showing the rigor behind all of the evidence, all of the detail behind what we're posting here for cloud operations and application owners. Even in the operational data, there's further details that we can extract, including that PDF report if we wanted to. To solve this particular ticket or to continue it or transition it, cloud operations needs to schedule a maintenance window. So they go down to runbooks over here, and they can see there's a runbook that's been associated to this ticket. So they just have to run this runbook. So they select it, they hit execute, and they can specify certain details behind this runbook. So start for example, the start date, when we want to execute this particular change. And they specify this in ISO 8601 format. So over here, they go ahead and they can specify some details on the specific time, the time zone in which we need to execute, the duration of the window, and the ops item ID. Okay, and they're going to go ahead and hit execute. And what's happening right now is the solution is actually going out, provisioning the maintenance window, going out to ServiceNow and updating ServiceNow, letting them know what the maintenance window details are, and so on. So you can see here, it should be done very shortly here. Okay, and there you have it. It ran successfully. If we scroll down a bit under operational data, we can actually see some additional keys that have been created with the maintenance window details. So you have the window ID, you got the cron expression when it's going to execute, and the duration of the window itself. Okay.
Now again, if we go back to ServiceNow and we go back to that change request, we'll see that all that when the dash updated that scheduled it, it's updated inside ServiceNow. So all that is specifically tracked in ServiceNow. So we're using the standard ITIL method of change requests.
Okay, so Blackened CloudFormation, we're gonna wait for maintenance window to trigger the update. So we're just gonna wait. Oh, there you go. So it's triggered the update, so we can see that it's in progress. In the EC2 console page, we can see that CloudFormation is updating these two instances, and we're gonna wait for it to complete the update. So it will shut it down. It will make necessary configuration changes and bring it back up. This is how you update an IaaS product within AWS. Okay, so you can see that the first web server product has been updated to the M5A 4 extra large, and the second one is being updated as well. They're both running updated. Go back to CloudFormation. We can see that it's just executing some cleanup activities. It should complete shortly, updated. And at this point, CloudFormation is reporting that it's been updated successfully. If we go back to the ops item, we can actually see the stack events in the ops item ticket. Now, I'm going to talk a little bit about, you guys have seen this already. So this is the, if you guys recall back to the slides that I was presenting, we talked a little bit about what we have to do to the CloudFormation template to enable this process, to enable CloudFormation to go on and extract recommendations from an external repo. I'm just going to give you guys a holistic view of the template that's driving this specific demo. So this is that web server template. And let's talk about some of the components in it to see what we have to do, what enhancements we have to make to our templates to enable this continuous optimization for not just new products, but for existing products. So we look under the resources component. There's a couple of elements here. You see the two main resources, the EC2 instances, the compute instance and the database instance. If you look at the instance type field, this is the field that's controlling the supply allocation. What size should it be? What family should it be running under? This is not being hard coded to say it should run as a C59 extra large. Instead, what we're doing here is we're saying, okay, for these infrastructure resources, just have it reference the Densify lookup plugin. Go to Densify and say, Densify lookup plugin, tell me what the value should be. So the bottom of the template where you have the Densify lookup plugin there, that's the resource that's supplying the optimal values back to CloudFormation. So if you look at that resource at the bottom, there's various different inputs. At the bottom, you can actually see the default values. So in the scenario where this is a brand new product being deployed and the resource plugin couldn't find any optimal settings in parameter store, it will supply the default settings set by engineering to say, this is what it should start off as and deploy them as such. And in the future, if Densify has a better answer, pick it up from parameter repo and send it to me. Okay, so three cases, right? Brand new create supplies the default. If it's already under continuous optimization in an update scenario, the answer will be in parameter repo. We'll pick it up and deliver it. I know some of you guys are thinking about the corner case, which is, what if this thing's gone through various different transitions? It started off as a C5, it's gone to an M, and now it's an R, and I'm issuing a stacked update, but for whatever reason, I'm in an error case where my parameter repo is down or the parameter doesn't exist. What's going to happen? Is it going to revert back to the original default? The answer is no. What the plugin will do is actually very smart. It's going to go and say, is there an answer in repo? If repo is not available or the answer doesn't exist, it's going to try to pull it from the actual resource itself. So it'll go to the EC2 instance and say, what is your current size? And if it exists, then we'll supply that current value back to CloudFormation to institute. CloudFormation will look at that and say, there's no changes, therefore I'm not going to touch it. Okay, but if it doesn't exist, of course, it's going to provide the default. Now, one last thing I'm going to point out about this template that we have, the one other enhancement that we have to make. If you look northbound, you'll see the parameter section. There is a parameter there that we define, and this parameter forces CloudFormation to create what we call change set. Without it, CloudFormation would just look at the incoming inputs to say, no, there's been no change, therefore there's no change set, therefore I'm not going to execute. So whenever we deliver a recommendation to parameter repo, we update this timestamp to say this is the last time we delivered this change, and therefore when you execute a stack update, if that timestamp is different, it will create the change set and execute this process. Okay. So with that, I believe we can continue with the demo.
All right. So now let's switch back over to ServiceNow, and we'll again take a look at this change request. And we can see that the state is under review. So it's under implemented, it's under review. So right now it's been scheduled because of the maintenance window. So I'm going to go here and I'm going to approve this and close this change request. And I'm gonna say successful. And I can put a couple notes here for audited purposes. So executed, no issues, save this. And now the change request is closed. As you can see here, if we refresh the screen, it'll go from review state to closed. All right. And we still have the open one that we can look at later. So that concludes it for our demo. So I'll give it back to Dinesh to.
Yep, if we could pull the, okay, so if we just jump over now.
Okay.
Perfect, Chuck.
Awesome, guys. That's truly a well thought out set of processes. And just to summarize, what we've got here is all of the agility, the ability for people to select from pre-approved and governed cloud resources, have their default requests, make their wishes known, knowing that Densify will be in the background, always working to recommend an analytics-driven optimal answer. So instead of hard coding stuff, which we see all the time, we're variabilizing it. And we're simply saying, we've got a better answer, would you please consider approving it? You know, whether it's through notification in a ticketing system, we can do it through Slack and Teams and collaboration environments. The whole point is to, again, enable that collaborative process. So thanks for showing that, guys. There are a number of questions, but I did want to point out some resources. If this is of interest to you, there are a number of things you can do as next steps. First of all, up on Git, there is a growing repository of information on this topic. There will be other additional innovations coming. Dinesh and Brian are working on some more automated deployment of this capability as an enabler, as well as detailed documentation and a coming blog on the topic. If you're interested in the Densify brain, which we hope you are, if you want to try it free against your infrastructure, we do have a free POC program. If you'd like to have just a more tailored demo of that part of what we've talked about here, always love to show our technology. Just throw a request in. We'll team you up with someone with some detailed knowledge on the technology, and they'll take you through it. Always happy to do that. And I'm sure Brian and the AWS team are available for same for the connector piece. I will call your attention to our next webinar, which is all about AWS savings plans and RIs as it relates to the Densify analytics. So if you're interested in that, easy to sign up. So that's our content for the day. I do want to transition to answer some questions, and while we're doing that, our team at Densify will be making that random selection of the people that stayed through our session, and we had a large number. So here I'm crossing fingers for everyone. No favoritism, of course. Lots of compliments, guys, on the presentation. Great presentation, asking for slides, etc. We will share the full recording of this presentation so that you can view it, play it for your friends and family, and enjoy it over again. But into some questions. Is this agentless, or do we need to install agents in each server, Dinesh?
No, we don't. Densify audits the environment using a completely agentless process. So we'll actually audit it via the the CloudWatch APIs, and we'll use other APIs within AWS to extract utilization metrics. Now the solution itself deploys as a serverless architecture for automation. So that would require the deployment of a few Lambda functions to host the actual solution and the orchestration.
And this is the kind of thing that would be custom for every customer, and through a combination of Densify, our partners, or AWS, we can help you get these things done. There's a question about production workload with DR. Let's say the workload goes through multiple continuous improvements, in quotes, by Densify. How is the DR target updated to support the DR plan?
So these business constraints and technical constraints are managed through our Densify policies. You can specify how we treat the DR site. So we could produce similar recommendations for the DR site based on what we're observing in the primary site, and that's controlled through the automation framework as well as it's delivered.
Just jumping here. How is Densify licensed? Densify is a subscription SaaS-based product. We deploy a dedicated instance by customer. We include an expert along with the subscription cost, and we price on an annual basis based on the number of instances you're analyzing, the number of workloads. And so if you have a smaller number, your unit price per year is higher. If you have a large number, that unit price goes down. Our teams are always available to give you an indicative price if you have an environment of a given scale. We choose not to price in the cloud based on a percentage of your cloud bill. We believe that that is a conflict of interest. So we simply price based on the scale of the environment that we're optimizing. A question on encryption in the plugins, those sorts of things. Is that a question you could answer, guys?
Yes, so parameter repo keys, they can be specified by yourself. You're going to use KMS or not. API access into the framework itself, you could specify your own authorizers or build your own authorization mechanisms for it. We do provide some out-of-the-box componentry for that. Okay. In terms of how Densify manages the keys, in order for the audit to complete, that requires a set of roles that we create inside your environment. These roles are provided to Densify, so to help facilitate the audit process for the recommendations.
There are questions about competing cloud environments. We do support other environments, but we've built this as a first run for AWS. We'll reach out and answer your questions later out of respect for our co-presenter. FedRAMP certified, we are not today, but we're looking for an excuse to go do it. So that's a great example. Question on deployment in multiple accounts. I know this is a big one, guys, and I know, Dinesh, you've done a lot of thinking and work in that area just for Densify itself, but can you speak for a moment on ease of deployment in larger or multiple account environments?
So if you're just talking about deploying Densify, we support complete mass deployments through CloudFormation. So we provide the CloudFormation templates for you guys to deploy inside your environment. That would get your Densify instance connected to your AWS environment. If you wanted to deploy that at scale across multiple accounts and regions, you can leverage AWS's CloudFormation stack sets to achieve that function. Now, in terms of the automation framework that we shared here today, the automated deployment mechanism is something that we're still working on. So once that's available, you're going to be able to deploy this at scale for the automation component to various different accounts and regions.
And if we look at the Service Catalog connector, it works for multiple accounts and multiple regions. So within the ServiceNow console, a user can order a product in an associated AWS account that you define within the connector or region.
Brian, are there any related costs for the connector or such to license and use that as an AWS customer?
So the AWS connector for both Jira and ServiceNow are completely free. And as far as the ServiceNow connector, you can go inside the ServiceNow store and just install it on your machine without any cost. Same with the Jira.
Free is good. Okay, I know Brian has a hard stop at the top of the hour. Heidi, do you have the winner's ready. Thank you everyone for your questions. There are more questions than we have time to answer here, which is fantastic. Lots of interest in this topic. We will follow up with each and every one of you to make sure that your questions do get answered and that you're directed. Encourage you to look at that Git repository. When we post this recording, we will post it on a page that has links to all of this stuff so that it's easy for you to find and engage with us to get more information.